Okay, so this is number 12 for Unit 6. A conducting rod having a mass of 0.1 kilograms slides without friction on two conducting rails 50 centimeters apart and inclined at an angle of 10 degrees with the horizontal. A uniform 0.1 Tesla magnetic field acts vertically upward. A battery attached to the rails causes a current to flow up one rail through the rod to the other rail and back to the battery. What must be the current and its direction of flow in the rod that will cause the rod to slide up the incline at constant speed? Okay, so the scenario is like this diagram that I drew here. So first, we will write the equation for the force due to a magnetic field, and we know that that is I B sine phi, because it's like cross product, and phi is the angle between the rail and the magnetic field. And since the rod slides up at constant speed, that means that this force has to equal the force or the component of the force of gravity that goes in that direction. So if we have gravity here, then we can split it up into its components, and then this component will be mg sine theta. So we know that this force equals mg sine theta. So if we solve for I, then we get mg sine theta over lb sine phi. And if we plug in numbers, so 0.1 kilograms and 10 meters per second squared. And theta is the angle here, 10 degrees. And divided by L is the length of the rail, which is 0.5 meters. The magnetic field is 0.1 Tesla as given in the problem. And phi is 80 degrees Celsius because this here is a right angle. We know that theta is 10 degrees, so phi has to be 80 degrees. If you solve, then you get 3.5 amps. And to find if the direction of flow of the current, because current is the flow of positive charge, you use your right hand. So your fingers point up because the magnetic field points up, and your palm faces towards the right because the force pushes the rod up the rails. And then you'll notice that your thumb points toward the left rail. So the current flows from the right to the left rail. And that is number 12.